a man-made island will soon rise from the waves of the North Sea. This is not a setting for a futuristic film. It is a real and ambitious plan from the nation of Denmark. The project has a clear and powerful goal: to create a massive hub for clean energy. By 2030, this artificial landmass could begin to power an entire nation. The scale of this undertaking is immense, one of the largest construction projects in Danish history. The vision: a new kind of power plant that floats in the middle of the ocean. This island will change how we think about renewable energy. The numbers behind this project are staggering. The Danish government has committed 210 billion kroner. This huge investment signals a deep belief in offshore wind. The island will cover about 120,000 square meters, roughly the size of 18 soccer fields. It will sit 80 kilometers from the Danish coast in the powerful winds of the North Sea. The timeline is aggressive. First phase operational by 2030. More than infrastructure, it is a bold statement of a green future. Why build an artificial island so far from shore? Because of the raw, untapped power of the ocean. Winds far out at sea are stronger and more consistent. The island provides a solid base in that high wind zone. It acts as a central gathering point for energy from hundreds of surrounding wind turbines. A solution to capture nature's power at unprecedented scale. This project is a pioneering step for Denmark and for the world. It will function like a giant electrical socket in the middle of the sea. Multiple offshore wind farms will plug into it. From this central hub, green electricity will be processed and distributed. Power will flow to Denmark and to several neighboring European countries. The island is key to a more integrated, resilient international energy grid, a cornerstone of Europe's transition away from fossil fuels, turning the North Sea into clean power for millions. The primary purpose of the energy island is to collect and manage wind energy on a massive scale. Offshore wind farms are not a new concept, but this project takes the idea to an entirely new level. Instead of each wind farm having its own costly cable to the mainland, they will all connect to the island. This hub-and-spoke model is far more efficient. It allows coordinated collection from an initial 3 gigawatts of offshore wind capacity, planned future expansion to 10 gigawatts, enough clean electricity to power 10 million European homes. Another critical function is stabilizing the power supply. Wind power is inherently variable. It fluctuates with the weather. Sometimes the wind blows hard, producing a surplus. Other times the wind dies down, dropping production. That intermittency is a major challenge for grid operators. The construction of the energy island is an extraordinary feat of marine engineering. The foundation of the island will be formed using massive hollow concrete structures called caissons. These are essentially giant, reinforced boxes. They will be built on land, then towed out to the designated location in the North Sea. Once in position, they will be carefully sunk to the seabed at about 26 to 27 meters deep. These caissons will be arranged to form a perimeter like the walls of a fortress. This outer wall will create a protected basin in the middle. Once the caissons are securely in place, the next phase begins. The area inside the perimeter will be filled with enormous quantities of sand and rock. This material will be dredged from the seabed nearby. This process will slowly raise the level of the enclosed area until it emerges from the water and becomes solid land. The outer caisson walls will also serve as a barrier protecting the island from harsh waves and storms. On top of this newly formed land, crews will build the infrastructure needed for the island to function: roads, buildings, a harbor. The island will be home to a vast amount of critical electrical equipment. This includes transformers, converters, switchgear. This equipment is necessary to handle the immense flow of power from the surrounding wind farms. The traditional approach to offshore wind power is straightforward but limited. In the past, each new wind farm was developed as a standalone project. It would have its own dedicated subsea cable connecting it directly to a specific point on the national grid. While this model works for individual farms, it becomes increasingly inefficient as the number of farms grows. The seabed becomes cluttered with a spaghetti-like web of cables. On land, the grid must be repeatedly upgraded in multiple locations to handle the new connections. This piecemeal approach creates logistical headaches and drives up costs over the long term. Denmark's energy island introduces a completely new paradigm. It acts as a centralized hub, or a plug-in point, for multiple wind farms. Instead of running long, individual cables to shore, wind farms can use shorter, more efficient cables to connect to the nearby island. The island then consolidates the power from all these sources. It uses a smaller number of high-capacity trunk lines to transmit the combined power to several countries. This is a much more organized and scalable system. It is like replacing a tangle of individual extension cords with a single, powerful, and smart power strip. The Energy Island's plan extends far beyond just transmitting electricity. A key part of its design is the production of green hydrogen. This process, known as electrolysis, uses electricity to split water molecules, H2O, hydrogen, H2, and oxygen, O2. When the electricity used for this process comes from a renewable source like wind, the resulting hydrogen is considered green. It is a completely carbon-free fuel. The island will have dedicated facilities to perform this electrolysis on a massive scale, using the abundant power generated by the surrounding wind turbines. Producing hydrogen directly at sea offers several unique advantages. One of the main challenges with electricity is that it is difficult to transport over very long distances without significant energy loss. By converting the electricity into hydrogen on the island, the energy can be stored and transported much more easily. The green hydrogen can be compressed or liquefied and then loaded onto ships for transport to industrial centers in Denmark and across Europe. This effectively turns the island into a green fuel station in the middle of the ocean, creating a new and flexible way to move renewable energy around the world. Green hydrogen is seen as a crucial tool for decarbonizing sectors of the economy that are difficult to electrify directly. Heavy industries, such as steel manufacturing, chemical manufacturing require intense heat that is often produced by burning fossil fuels. Green hydrogen can be used as a clean alternative fuel for these processes. Similarly, heavy transport like shipping, aviation, and long-haul trucking. There is no question that the Danish energy island is a high-risk, high-reward venture. One of the most significant challenges is the sheer engineering and construction complexity. Building a stable structure 80 kilometers out in the notoriously rough North Sea is a monumental task. The project will be exposed to extreme weather, powerful storms, massive waves, which can cause costly delays and pose safety risks to workers. Long-term durability of the island's structure is a major technical hurdle. Protecting sensitive electrical equipment from corrosive salt water is another. The financial risks are also substantial. A price tag of 210 billion kroner makes this an enormous public and private investment. There's a real risk of cost overruns, common in mega projects. Critics say the money could fund other, potentially less risky renewables instead. Economic viability depends on long-term electricity prices, the cost of technology, and successful international agreements for power sharing. If these factors shift unfavorably, financial returns could be jeopardized, leaving taxpayers with a heavy bill. Beyond technical and financial risks, political and regulatory challenges remain. The island is designed as an international hub connecting multiple countries' grids. That requires agreements on how the infrastructure will be used. In conclusion, Denmark's North Sea energy island is much more than just a large construction project. It represents a fundamental shift in thinking about how to harness renewable energy. The plan is audacious, using immense numbers and bold engineering to tackle one of the world's most pressing problems. By creating a central hub for a vast network of offshore wind farms, the project aims to capture the power of the ocean winds at an unprecedented scale. This centralized model promises to make the entire system more efficient, stable, and cost-effective over the long term. The project's integration of green hydrogen production is a particularly forward-looking feature. It addresses the critical challenge of storing renewable energy and transporting renewable energy, while also providing a clean fuel source for industries that are difficult to electrify. This dual-purpose design elevates the island from a simple power station to a comprehensive energy and industrial hub. The world will be watching closely as Denmark navigates these challenges. The lessons learned from this project, both successes and failures, will be invaluable for other nations. Ultimately, the Danish energy island is a beacon of hope. If this man-made landmass in the North Sea succeeds, it will not just power millions of homes. It will provide a new blueprint for clean energy development around the globe.